quickly get started with the first example. Okay, so the example is already flashing on your screen. The first question is, it is going to be little easy, but then we are going to increase the difficulty level example by example. Okay, so the first question is, a coin is thrown 3 times. What is the probability that at least one head is obtained? Okay, now I am going to solve this example by using 2 different ways. Okay, just to clear your concepts. Okay, so it's not that, okay, this is the only way to solve this problem. Okay, probability is all logical, correct? So yeah, let's start solving this with the first way. So what are they saying? A coin is tossed 3 times. Yes, so assume that first time when the coin is tossed, what are the outcomes from that coin? Okay, so 2 outcomes are either it is going to be head or tail. Yes, so basically this is the sample space, correct? When the same coin is tossed for the second time, again what is the sample space? Again H and T, head and tail, correct? And third time when the coin is tossed, again the same set of output you will get, correct? So these are nothing but your sample space. So how many elements are there here? 2, here 2, here 2, right? So what is going to be the total sample space when the coin is tossed 3 times, correct? We are not interested in the each run, correct? We are basically looking for the outcome after tossing the coin 3 times. So the combined output we are interested in. Okay, so how many elements are going to be there in the total sample space when the coin is tossed 3 times is nothing but 2 into 2 into 2. You getting? So this is the Cartesian product basically. So n of s you can say is nothing but what? 2 into 2 into 2. It is 8. Okay. Now when you want to find out the actual outcomes, correct? All the total outcomes means the set sample space is nothing but what? Again take the Cartesian product of these sets one by one. First we will take Cartesian product of these 2 and then we will take the obtained one and the last set. Okay, that way it becomes very easy. Okay, so when you take the Cartesian product of these 2 sets, you get the output as what? HH, correct? So it is going to be what? Let me just remove the bracket and everything. We'll simplify this. Okay, so first is what? HH. Next is what? HT. Yes. Next is what? TH. And the fourth is TT. Yes. This is one set. And Cartesian product with what? This third set, which is nothing but what? HT. Correct? Now take the Cartesian product of this with this. So H, H, H. Next is what? H, H, T. This way it becomes easier, right? To find out the total outcomes. Okay, done with this H, H. Now H, T. H, T, H. H, T, T. This is done. Now T, H, H. T, H, T. This is done. Now T, T, H and T, T, T. So the benefits of solving or finding out the sample space by using this Cartesian product way is you do not miss any outcome. Yes, correct. It is a bit easier this way. Okay, this is the sample space you obtain. Now let's move to the event which they are saying. What's the event? Event says that at least one head needs to be there. Is it right? Now straight away you can see in this sample space at least one time means one or more than one times head has to be there. So at least one or more time head should be there means all of these are valid outcomes, correct? Only this TTT you should not be considering, right? So basically n of this event is what? 7, right? Only this one is to be excluded, correct? And these 7 are the valid outcomes, right? And when you have this n of E, n of S, probability becomes very easy. Yes, you already have seen the formula for that. Yeah, what is that? Probability of an event is equal to number of favorable outcomes divided by total outcomes. Yes, okay. Now the basics and the logics behind these are already covered in the previous video or part 1 you can say. So what is n of E? 7. Yes, favorable outcomes and total outcomes are 8. So this is the answer for your question. Okay. Now the other way, that is also very interesting. Okay, in that way you don't have to find out this sample space at all. Yes, sounds interesting, right? Okay, so any event, any probability lies between 0 to 1, including 0 and 1. when we are saying that at least one head should be obtained, can I say that the total probability minus no head should be obtained will give me the same result? You getting my point? Because see, why I am moving to this way? Because by using the previous way, I had to find out all the outcomes first, sample space first, then I had to count wherever H appears, right? That becomes a little bit lengthy. But what if I find out like no head? Suppose I consider the event as no head should appear. No head should appear means what? All should be tail. TTT. That's the only outcome. Correct? And if I subtract that from the 1, that will give me the actual result, that at least one head. So my point, please note this point here, trick and tip you can say, whenever at least word comes, that gives you the number of outcomes and the lengthier way. So in that case, you can always go with this way where you find out the opposite event and then subtract that probability from 1. That is the easier one. Probability of an event is equal to 1 minus probability of the opposite event. Correct? Okay. So if I want to find out the probability of having at least one head, what I would do, I would find out the probability of no head. Probability of having no head means only one outcome is there, correct? That is TTT, where there is no head at all. Yes, and then I would subtract that probability from this one to get the actual result which they are asking me for. Okay, so yeah, so now this is one, correct? Maximum probability. Now, what is P of E dash? E dash is what? No head divided by total outcomes. No head means what? Only one, correct? One, correct? Only TTT divided by total sample space. That is going to be the 8, still the same, correct? So now if you do this calculation, 8 minus 1 means 7 by 8. Yes, 7 by 8, 7 by 8. Easy. See in how many steps you did this? Just in these 2 steps. So, okay. So this is also logical. This is also kind of logical, but then this is lengthier way. That's what I'm trying to tell you, okay? So whenever at least word comes, you can always go with the opposite method in which you find out the probability of the E dash, that is the opposite event, and then subtract it from 1. That will give you the same result. Okay, now let's go to the next question. Okay, so the second question is, find the probability of getting a numbered card when a card is drawn from the pack of 52 cards. Okay, so now see, you must be aware of the cards basically. Okay, that's the prerequisite to solve such card related examples. Okay, I will quickly tell you, I am going to upload the other video in which I will explain you the cards in detail. Okay, but for now you must know like honor cards, then what are cards basically, what are suits or types of cards, then honor card, numbered cards. So I'll just quickly give you that overview here. Okay, so basically when you have cards, okay, so in total there are 52 cards, easy, okay, which are further divided into 4 types or suits you can say. Okay, so the first or I'll just write down their symbols. This is known as spade, which is in black color. This next is what? Club, that is again in black color. Okay, now next is what? Heart. You already know the heart shape, yes? So that is in red color, and this is diamond, which is again in red color. Okay, 13 cards in each suit. So these are 13, 13, 13, 13. Okay, now again we'll go suit wise. Okay, in all the suits this is applicable. So, okay, so suit wise when you go, it is further divided like honor card, okay, honor card and numbered card. Okay, honor card and numbered card. So honor card is nothing but what? Ace, jack, queen and king. And numbered card means those are the numbers from 2 to 10. Okay, so you will say ace is nothing but 1. So why isn't in honor numbered card? No, because ace has some different position in cards. Okay, that is as honorable as jack, queen and king. Okay, so basically this is the card concept. Okay, now why is it so? That is not for this video definitely. Okay, so honor cards are basically ace, jack, queen and king for each suit. Okay, and numbered card means the cards from 2 to 10 again for each suit. Okay, now you will if you understood this basic concept, you would be able to solve this problem. So from the pack of 52 cards, you are what selecting just one card, correct? And that card needs to be what? Numbered card they are saying. How many numbered cards are there? Okay, so numbered card, selecting numbered card is your event, correct? how many possibilities are there? How many numbered cards are there basically? See, total, if you take the total these are what? 9 cards including 2 and 10. Yes, you can count 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are 9 cards. So 9 cards in each suit. So 9 into 4 is 36. So 36 is nothing but your total numbered cards, means total favorable outcomes, right? And how many total outcomes are possible when you are selecting just one card? So total cards 52, correct? You can always select any of them, right? So this favorable outcome divided by this total outcome is nothing but the probability of this event, probability of obtaining the numbered card event. Yes, easy. You can do the simplification part. That is not for me. So now next question is, there are 5 green and 7 red balls. 2 balls are selected one by one without replacement. Important word, okay? Find the probability that first is green and second is red. Okay, now let me just write down what are they saying. Okay, so these are the 5 green balls. Okay, and what are they saying? 7 red balls. 1, 2, 3, 4, 5, 6, 7. For explanation purpose, I am doing it this way so that I clear your concepts, okay? And you don't have to mug up any formula or anything in such examples, okay? So understand the concept now, okay? So these are the balls given to you, 5 green and 7 red. These are 5 green balls and these are 7 red balls. How many balls you have to draw? 2 balls are selected. You remember permutation and combination? Selection is nothing but C, combination, okay? We'll relate that with this example later. So again, I will show this example by using 2 ways. Okay, you can do it in any way, or you can still figure out the third way also if you go logically. Okay, so the first way, which is very simple and straightforward. So you have to find out the probability of the event. What's the event? The first ball should be, the event says that first ball should be green one, and you know that, right? And means multiplication. The second ball needs to be red one. Okay, so these 2 probabilities you have to find out to find the probability of the total event. This is nothing but your total event, correct? So what is the P of probability of having green ball is nothing but n of G divided by n of S into this is n of R divided by n of S again. Yes. Now n of G is what? Total green colored balls. How many are there? 5, correct? What's the condition? First ball needs to be drawn green, which has to be green one, correct? So this is selected from these 12 balls. Total sample space is 12 balls, correct? 5 plus 7. And now n of R is how much? 7 divided by. Now see carefully. Now this is going to be what? 11. Why? Because they are saying without replacement, correct? One after another they are selecting balls. So when this event happens, you already have selected one green ball, any one of them. Okay, say for example this ball is gone now. Okay, now the turn comes for the second selection. So when you are selecting this second red balls are still untouched. So 7th red is there, correct? But then total sample space is changed, correct? Because you removed and you are not allowed to replace it again, correct? So this is gone. So total sample space is 11 now, right? And when you do this calculation, you get the answer, okay? Now as I promised you, we'll solve this by using one more way where combination comes into the picture, because you have seen the combination and permutation also very logically. Okay, now see, let's fit that logic here. Okay, let's say that this is again the same thing. You have these 5 balls intact. Okay, now what is the event basically? You have to select one ball from green, and after that you have to select one ball from red. Okay, so what is that? N of E. N of E is nothing but what? You have to select one ball from these 5 balls, and you have to select the one ball from these 7 balls. Is it correct? So that is going to give you n total number of possibilities. Yes, these are the favorable outcomes. Now divided by, what is our formula? Divided by total number of outcomes. That is going to give you the probability, correct? So how do you find out that total sample space equals to? Now see, here you won't be able to do it 2, correct? Total balls are like 12 and 12C2 because you are selecting 2 balls. No, that is not the case. Here this is wrong. You are selecting one ball at a time and then keeping that aside, right, without replacement, and then you are selecting the next ball, correct? So first ball is selected from all the 12 balls, correct? That is the sample space. Now forget about the condition. And the next ball is selected from remaining 11 balls because this one ball is gone, correct? And then you again take the division of these two is nothing but your probability, correct? N of E upon N of S is your probability. Solve this. This is kind of easy. When it is 1 there on the lower side, it is straight away 5 into 7 divided by 12 into 11. You can do the calculation part. It's the same thing, correct? What you get here. So I hope this is helpful. Let's go to the next question. What is the probability of getting a sum of 7 when 2 dice are thrown? Okay. Sum needs to be what? 7. That is an event. Okay. Sum has to be 7. And what is the experiment or sample space? How are you going to get? It's nothing but what? 2 dice are thrown. Okay. Now, I am not going to find out the complete sample space. You getting my point? I am not going to find out all the outcomes of the sample space. No need of that, correct? That is time consuming. What I'll do rather, see now, 2 dice are thrown. Okay. What are the outcome when 1 die is thrown? Right? So, 1, 2, 3, 4, 5, 6. Correct? And similarly, the second die is also thrown. So, 1, 2, 3, 4, 5 and 6. Correct? And then when these 2 dice are thrown, you are going to get what? Various combinations. Either it can be 1, 1, 1, 2, 1, 3, 1, 4, same way 2, 1, 2, 2. You getting my point? So those total combinations are going to be how much? 6 into 6, because there are 6 elements in this, 6 elements in this. So N of S is nothing but what? Cartesian product. 6 into 6 is 36. I am interested in only this N of S, right? And I want to find out what? N of E, so that I would be able to find out the probability after that. Now what is N of E? What is the event they are saying? Event is to have the sum as 7. Okay. Now I don't need the complete sample space for this. Just by looking at these 2 sets, I can still figure out the set, this set, correct? So N of E you need to calculate. For that, E is equal to what? Total should be 7. So if I take the combination with 1, so definitely it needs to be 1 and 6. Correct? Then only it is going to make the total as 7. So when 1, 6 is there, if you reverse it, it is going to give me 6, 1. That is also possible, right? 6 on the first and 1 on the second. If I take 2 on the first one, then that is going to give me 5 on the second one, correct? To make it make the total as 7. Again, the reverse is also a valid condition, 5 and 2. Yes, if I take 3 here, so that is going to give me what? 3 and 4. So again the reverse is possible, 4 and 3. Yes, if I take 4 here, so 3. So that we have already covered. So how many elements are there in this event, or how many outcomes are there in this event? Favorable outcomes 1, 2, 3, 4, 5 and 6. So N of E is what? 6. Yes. What's the formula of your probability? Probability of an event is equal to total number of favorable outcomes divided by total number of outcomes. What are the favorable outcomes? 6. Total outcomes 36. 6, 6 are 1 by 6 is the probability and is the answer to this question. Let's quickly take the next question in the easiest way. Okay, so that is related to the cards, and that is why I did not erase this part. Okay, because there are some more upcoming questions on cards. One card is drawn at random from the pack of 52 cards. Only one card you have to select. Okay. 52 items or outcomes are there in your sample space. Clear up to this? First probability you have to find out is it is an honor card, and second is it is a face card. Very easy question. Okay, so what is the first? It has to be the honor card. How many honor cards are there in one suit? See, these are 4 honor cards, as I told you already. So these are 4 in one suit, and there are total such 4 suits or 4 types. So total what? 16 favorable outcomes are there, correct? When you go for honor cards, divided by what? Total outcomes are how many? 52. Correct? It's a pack of 52 cards. Total 52 cards are there in all the packs. Okay, so first question is done. Now what's the second part of this question? It has to be what? Face card. Okay. Now face card means Jack, Queen and King. These are your face cards because you have pictures on this card. That's why these cards are known as face cards. So there are 3 face cards in one suit, and there are such 4 suits. So this is what? 12 favorable outcomes divided by, again you are selecting that one card from this whole card set of card, which is 52. So this is your second answer. Now see, this is very interesting one. Okay, 2 cards are drawn from the pack of 52 cards. Okay, find the probability that both are diamonds or both are kings. Okay, now see, when there is just one card selection, you would be able to do in this way directly as we did in the previous example. But when more than one cards are drawn or selected, you have to go with the combination, because see, out of 52 cards you are selecting 2 cards. So just imagine how many combinations would be there. You won't be able to find out the sample space in that way, correct? And that is when you use the concept of P and C, permutation and combination. Okay, so right now you are selecting 2 cards from the pack of 52 cards. So what is the sample space? So N of S is nothing but what? Out of 52 cards, you are selecting 2 cards, correct? So that is nothing but your 52 factorial divided by 2 factorial into 50 factorial equals to 52 into 51, that 50 goes divided by 2. Yes, 2 2s are 4, 2 6s are. Then, so that is nothing but what? 26 into 51. These are the total number of outcomes. You getting my point? And that's why you won't be really able to find out the actual outcomes, correct? And you don't have to go with the combination concept now. Okay, and what is the condition now? So these are the total outcomes. Okay, that is done. But then what is the condition or event? They are saying both are diamonds or both are kings. Okay, so the event is what? Both should be what? Diamonds. Or, okay, both should be kings. Okay, so now see, again you will use combination here because more than one cards are selected. See, now you are selecting 2 cards or from the total diamonds. How many diamonds are there? 13 diamonds. Or means plus sign. Yes. Select 2 cards in which both should be kings. How many kings are there? 1 king in each suit. So in total there are 4 kings in all the total 52 cards. Okay, 4 kings are there. So this, when you solve this, you get what? N of E. Correct? What is N of E? I am not going to solve this completely. Just a hint. 13 factorial divided by 2 factorial into 11 factorial plus 4 factorial 2 factorial 2 factorial. Correct? You simplify this part. And now what is the probability of this event which they are actually asking you? Is nothing but this N of E divided by N of S. So this is the N of E. Yes, this complete is N of E divided by what is N of S? 26 into 51. So when you do this, see, it looks complicated, it is not really. Okay, I'll just give you the hint. Okay, see, now this is what, if you simplify, 13 into 12, 11 goes there, so divided by 2 only, plus this is what, 4 into 3, again 2 goes there, only 1 2 is there, right? If you solve this, 2 6s are, 2 2s are. Okay, you have to do this now. 13 into 6 is how much? 78. Yes, plus this is 2 3s are 6. So 78 plus 6 is how much? 84. So this is nothing but what? 84 divided by this 26 into 51. Now you do this final calculation and that is your answer. See, I had decided not to give you any hint for calculation because you need to be quick with the calculation part. Okay, that's not the concept we are learning here. Okay, so that is the calculation part which you have to do, right? So yeah, I hope this is clear. Let's move to the next question. Okay, so next very interesting question. 3 dice are rolled together. What is the probability as getting at least 1/4? See now, see carefully. As I told you, okay, I have given you the hint that when word at least comes, you go the opposite way. You find out the E dash and then you subtract that probability from 1, okay, to get that E. Because at least word has many choices or many combinations. So this is very difficult to find out such event directly, manually. So you go the opposite way. That is one thing here. Now 3 dice are rolled together. Just imagine if you try to find out the sample space total. So you don't really have to find out the total sample space, right? So there are basically 3 dice which are rolled, right? When 1 die is rolled, what's the outcome? 6. Total 6 outcomes are there. For next again 6, for next again 6. So this is nothing but what? Your sample space. We have already seen such things or such calculation in the previous examples. Okay, so this is what you got, the one part. Okay, one part for sure. Now what you are interested to find out the probability of an event. Event is what? You should have at least 1/4. But then how you are going to find it out? 1 minus P probability of E dash. E dash is what? Opposite event. What can be the opposite of at least 1/4? Opposite is no 4 at all. Understood? So you are now going to find out such probability of the event which has no 4 at all on any of the dice. Clear? So let's see how that is done. So this one minus part is as it is, and let's focus on this probability now. Okay, so when you have on the first try, say outcomes are 1, 2, 3, 4, 5 and 6, correct? What you are saying, what this event is saying, 4 needs to be excluded, right? That's what this E dash event is, right? No 4 at all. Total favorable outcomes can be what? 5, correct? Divided by, what are the total outcomes including that 4? 6. So that is one probability on for the one die. Same way, and you can have it for the second die also and for the third die also. Yes, this is how you got to the P of E dash, correct? You are finding out this probability. Probability is what? Favorable outcome divided by total outcome. This is for first die, then for second die, and then for third die, and you are doing and of this, correct? Because 4 should not appear on any of the dice. Yes, that's what you are finding out. And once you get this solution, you subtract it from 1 to get the actual question's answer, which is what? What's the actual event? You should have at least 1 4. Okay, more than 1 4s are also possible. So you always take the opposite, find out the answer for this, and that is much easier to find out, and that is why you go with this way when you have the word something like at least in the question. Okay. Okay, so I hope this video helped you to understand the concept of probability and to solve the variety of examples on probability. Okay. Now, as a homework for you, one question is flashing on your screen, correct? And that is very simple. I know that is very basic, but then the basic of probability you must know by now. So just read that question and share your answers with me in the comment section or with me privately directly. I hope this video helped you a lot. Like, share and subscribe to my channel. Share it with those who really need to watch my videos. Okay, keep studying, keep practicing. Bye-bye.